Hi, so we are going to take a look at equilibrium today. And we're going to do that using the activity that is on page 1017 of your binder. So we're in Unit 10. The activity is called an equilibrium simulation with water. So before we actually start the simulation, let's take a look. I got a couple things written on the whiteboards. So equilibrium can be defined as a balance between opposing forces. Now, what those opposing forces are, obviously, is going to vary. In chemistry, equilibrium occurs when you have a reversible reaction. If you remember in the kinetics unit, we saw that potential energy diagrams can be used to represent reversible reactions, where once you've made the products can actually recombine to create the reactants. So the reaction goes both directions, in the forward and in the reverse reaction. So for our simulation today, we're going to do something very simple. We're going to do A back and forth yields B. So notice that for a reversible reaction, we've got that double arrow there. So A is going to produce B and B is going to produce A. So now take a look at the equipment that we're using. I've got two straws. Notice that they have different diameters. And I've got two graduated cylinders. One of them I've already filled with 50 milliliters of water. I've made it red so that you can see it against my white shirt. And then this one is completely empty. So this represents A. This graduated cylinder represents B. And what I'm going to do is I'm going to put the straws in, transfer liquid, and read the volumes. And I'm going to do that as many times as it takes in order to get to equilibrium. So now I want you guys to take your best shot. What do you think the volumes are going to be when I reach equilibrium? I want you to pause the video and I want you to write down a prediction. What do you think the volumes will be? And they don't have to be exact, just approximate. What do you think the volumes are going to be when I reach equilibrium? What will equilibrium look like? So pause the video and do that, okay? All right, so we're back. So I'm gonna start collecting data. If you notice, I've got a data table here. My first reading is graduated cylinder A has 50 milliliters, graduated cylinder B has nothing. I'm going to continue to collect data. Now you're looking at that data table probably going, oh my gosh, do I have to sit here and watch her collect that data the whole time? The answer is no. We're going to do some movie magic and collect the data much more quickly. And I'll share the data table with you at various times, but no, you don't have to watch this video and watch me transfer it every time. I'm going to do a couple. We'll record the numbers so you get a feel, and then we'll come back and get some more data after I get transfers done outside of you. Okay, so the idea is I'm going to put both straws in. The big straw is going into A. The little straw is going into B. And I'm in deep trouble because this big straw isn't quite long enough. Okay, pause it. So that first white straw was too short. I went and grabbed a new one and we're back. And so now we'll be able to do our first transfer because I can actually get my fingers on this. So what I'm going to do is put my finger over the top of the straw. I'm going to raise it up and transfer the liquid simultaneously into the other straw. Gonna bang it out a little bit and we're gonna record the volume. Now this first volume I might not be able to get because I need at least 5 milliliters in order to see a line, and I don't have it yet. So what I'm gonna do for this first one is I'm gonna read this volume and just subtract from 50 to get what's in graduated cylinder B. So I have 45.2 milliliters here, and which means then I have 4.8 milliliters for the first one. Now the next transfer, I'm going to be able to read this volume, so I'm not going to subtract. I'm going to read the two volumes appropriately. Okay, so let's do this again. You want to try not to lose the liquid. It's going to be a little hard. These straws are shorter than what we normally use in lab. So you want to try not to lose the liquid. I'm going to transfer simultaneously a little liquid coming out of the B straw and a lot of liquid coming out of the A straw. And now in A, I have 41.4. And in the B straw, I have 7.2. Okay, so I'm going to continue to do that a little bit more, and then we'll come back and see where I'm at in a few minutes. Hi, so we are back. I did a bunch of transfers, and as you can see, I have almost the same volume in here. A is 24.4, B is 23.9, and I'm losing a little bit of water along the way. So some of you may very well think, I'm at equilibrium, these values are equal. And if we were in classroom and you called me over and said, Mrs. Plata, we're done, I'd say, no, you're not, keep going. So if you predicted that we would be at equilibrium at 25 and 25, you were wrong. We need to keep going. So here I go some more. Okay, so we have finally reached equilibrium. You guys will be grateful that I'm the one who went through all the work and you didn't, because it takes a little bit of time. So notice that we've hit this volume and it has kind of stabilized. The volume in graduated cylinder B has not changed. The volume in graduated cylinder A has not changed. That's how I know I'm at equilibrium. So take a look at my data. There's a lot there. So notice that at one point, I had 4 in a row that were the same. I thought I was at equilibrium, but then shoot, it changed. And then it continued to change, and I had more in a row, and then for some reason it continued to change. And so I quit when eventually I knew that things weren't changing anymore. And now I know that I'm at equilibrium. So equilibrium is a balance between opposing forces, but it's not obviously equal volumes. So you've got to figure out what's equal. We've got one last step to do in our lab activity, and that is to measure the amount of liquid that straw B picked up from graduated cylinder B and straw A picked up from graduated cylinder A. So I'm going to do A first, reach down in, grab some liquid, and record this volume. This volume is 1.40 milliliters. So graduated cylinder A is 1.40 milliliters. Okay, I'm going to do the same thing, or not graduated cylinder, tube. Straw B, going to reach in and pick up liquid. I'm just going to add it, and I'll get my volume of B from subtracting. That's easier than trying to dump a little bit of liquid that was in here out. So I've got, doesn't that work out nicely? 2.8 milliliters. So 1.4 from A, 2.8 from both of them, which means 2.8 minus 1.4 is 1.4. So the amount of liquid that both straws picked up was 1.4 milliliters. Okay, use that to help you. Now, some of you may notice that I've got a lot of pink drops on here. And if you add my volumes, if you add the volumes up at the end, 18 and 29 does not add up to 50. That's okay. Even though we're losing a little bit of water, we were still able to establish equilibrium eventually. That's probably why it fluctuated a little bit. I did something and lost a drop and had to kind of not start over, but had to reestablish where that equilibrium was. So what you're going to do now is take this data, and we'll show it to you one more time. We'll hold it there for you so you can look at it. And you're going to use it to answer the analysis questions that you have in this activity. There are 5 questions, and then you're going to write a summary. Don't write the summary until we have a chance to talk about the other 5. So answer the first 5 analysis questions, go to the video that discusses the lab, and then your grade will be based upon what you write for number 6. All right, thanks guys, good luck.